Bismillahirrahmanirrahim. Today's my lecture is about osmosis and tonicity. At first, osmosis. Osmosis is defined as the movement of water or any other solvent from an area of lower concentration of solute to an area of higher concentration of solute through a semi-permeable membrane. The semi-permeable membrane permits the passage of only water or other solvents but not the solutes. Osmosis can occur whenever there is a difference in the solute concentration on either side of the membrane. In this figure, osmosis occurs at the cell membrane when a sodium chloride solution is placed on one side of the membrane and water is placed on the other side of the membrane. This figure taken from Physiology book, which is written by the Guyton. In this figure, movement of water across a semi-permeable membrane, that means osmosis occur towards ion or solute rich region in a solution. In this figure, osmosis occur, that means water molecule which is bound to the solute cannot pass due to size. Only unbound molecule passes through the phospholipid of plasma membrane, which is semi-permeable. Osmosis depends upon osmotic pressure. Let us, what is osmotic pressure? Osmotic pressure is the pressure created by the solutes in a fluid. During osmosis, when water or any other solvent moves from an area of lower concentration to the higher concentration, the solutes in the area of higher concentration get dissolved to the solvent. This creates a pressure which is known as osmotic pressure. Here we create the osmotic pressure. Normally, the osmotic pressure prevents further movement of water or other solvent during osmosis. In this figure, dotted line is semi-permeable membrane, and in figure 1, the concentration of solute is high in B compartment and low at the compartment of A. So, water moves from A to B through a semi-permeable membrane, and in tube, entrance of water into B and exert osmotic pressure. Let us know some term. At first, reverse osmotic pressure. Reverse osmosis is a process in which water or other solvent flows in reverse direction, that means from the area of higher concentration of solute to the area of lower concentration of solute if an external pressure is applied to the area of higher concentration. Then colloidal osmotic pressure. The osmotic pressure exerted by colloidal substance in the body is called colloidal osmotic pressure. Then oncotic pressure. The osmotic pressure exerted by colloidal substance, that means protein of plasma, is known as oncotic pressure. It is about 25 mm of mercury. Osmosis across the cell membrane is of two types: endosmosis and exosmosis. Endosmosis means movement of water into cell, and exosmosis means movement of water out of the cell. In this figure, what will happen in this tube if water is freely moved through the membrane but glucose are not? Answer is, water moves from the side with high concentration of water to the lower concentration of water, and movement stops when osmotic pressure equal the hydrostatic pressure. Hydrostatic pressure means forces of fluid volume against a membrane. Then tonicity. Tonicity is the ability of a solution to affect fluid volume and pressure within a cell. It is a measure of effective osmotic pressure gradient, the water potential of two solutions separated by a semi-permeable membrane. Tonicity depends on the relative concentration of selectively membrane permeable solutes across a cell membrane which determine the direction and extent of osmotic flux. There are three types of tonicity: isotonic, hypotonic, and hypertonic. At first, isotonic. Isotonic is the solution that have the same concentration of solute as a suspended cell. That means normal saline. What happens when a cell is placed in an isotonic solution? Answer is the cell will have no net movement of water and will stay the same size. Example is blood plasma, which has high concentration of albumin molecules to make it isotonic to tissues. Secondly, hypotonic. The solutions that have lower solute concentration than a suspended cell. That means cytosol have high water concentration. What happens to a cell when placed in hypotonic solution? The answer is the cell will gain water and swell and may be burst. If the cell is burst, then we call lysis. In case of red blood cell, we cause hemolysis. Then hypertonic solution. The solution that have a higher solute concentration than a suspended cell, that means cytosol have low water concentration. What happens when a cell is placed in a hypertonic solution? The answer is the cell will lose water and shrink. In case of red blood cell, we call this crenation. In the red blood cell, this feature occurs. In a sentence, we can say, in isotonic solution, cell neither shrink nor swell. And in hypertonic solution, cell shrink. And in hypotonic solution, cell is swells. Why osmosis is important in cell? That means in human, there are three important things. At first, cell remove water produced by cell respiration. Secondly, large intestine cell transport water through bloodstream. Thirdly, kidney cell form urine. Thank you for your patience hearing.